So in this video we're going to look at stoichiometric coefficients. This will come in two parts, and this is the first part of the video. So in the first part we're going to consider simple reactions. Now by simple I mean the case where a given species, say in this case A, only occurs on the reactant side and does not occur on the product side. Likewise for B. B only occurs on the product side, does not occur on the reactant side. So this is what I mean by the simple case. In the next video we'll look at the case where A can appear on both sides or B can appear on both sides. Now you remember before that we talked about stoichiometric amounts. So these are the little numbers that appear in the front. If there are no numbers, the implication is that the stoichiometric amount is 1, but I'll put them in here explicitly just to show you. So this just tells us that 1 molecule of A is transformed to 1 molecule of B. Now I'm going to use the following symbols to indicate the stoichiometric amounts. So I'm going to use alpha to indicate reactant stoichiometric amounts, and I'm going to use pi to indicate product stoichiometric amounts. So we only have two here, so there's alpha A has a stoichiometric amount of 1 and pi B has a stoichiometric amount of 1 as well. Now what about the stoichiometric coefficients? Well, there will be as many stoichiometric coefficients as there are species in the reaction. In this case there's two species, A and B. So let me write down symbols for the stoichiometric coefficients using the symbol C. So there's only two. So what are the stoichiometric coefficients? Well, whenever you have a stoichiometric coefficient for a reactant, it'll always be negative. Whenever you have a stoichiometric coefficient for a product, it'll always be positive. We then simply follow it by the stoichiometric amount, which is alpha A in this case and pi B in this case. So that means d equals minus 1, that equals plus 1. Okay? So it's actually quite easy to write these down simply by inspection. You simply list, so for all species on the reactant side you just list them out. For all species on the product side you list them out. You make all the reactant stoichiometric coefficients negative. You make all the product coefficients positive, and then you just use the stoichiometric amount as the number to follow it. So to give you another example, let's have one a little bit more complicated. So let's say we had 2a plus b gives 3c plus d, for example. So I won't bother writing out the alphas and pi's in this case, and let's just do it by inspection. So there are 4 species in all, A, B, and C. And again, note that this is the simple situation where A only appears as a reactant, doesn't appear as a product. B likewise. C only appears as a product, not as a reactant, and D likewise. Now since there are 4 species, there will actually be 4 stoichiometric coefficients, which I'll just list down here. And remember, the rule is that for all reactants, which is A and B, they have to be negative, and for all products they have to be positive, and then we just follow each one with the stoichiometric amount. So the stoichiometric amount for A is 2, for B is 1, for C is 3, and for D is 1. And those are the stoichiometric coefficients. Now the next slide, in the next video that'll come along, consider the case where a given species can occur on both sides of the reactant and product side.